Uses of friction. Welcome to our video by group FL3. What will we learn in this video are what is friction, what are the formula that involved in friction. We also going to see some examples and friction in our daily life. Firstly, definition of friction. Friction is a force between two surfaces that are sliding or trying to slide across each other in different directions. Forces that opposes the motion of an object. Formula that involved in friction is F is equal to mu n, which is F is stand for frictional force, mu is stand for coefficient of friction, and n is stand for normal force. Example 1. Skating. A thin film of water under the blade is necessary to make the skate slide. The heat generated by the skate blade rubbing against the surface of the ice causes some of the ice to melt right below the blade where the skater glides over the ice. This water acts as a lubricant reducing friction. Example 2. TYRE. TYRE flowers have a lot of different patterns and different uses. TYRE flowers are made to increase the frictional force between the tire and the road. There are so many types of tire. For example, drift tire, MotoGP tire, and motocross tire.
Concept of friction force at tire. When tire moving, rolling resistance occur between the tire and the road. Friction force for accelerating points parallel to the tire movement, while friction force for braking points to the opposite side. Given 248 kg object and the velocity 90 meter per second from the rest. So we use the equation v square equals to v object square plus 2ad. Substitute the value into the equation. Solve for a equals to negative 4.75 meter per second. To find mu k, we derivation from this equation. Net force equals to mu n equals to mu mg. Net force and frictional force is ma. So mu k equals to negative ax over g after we cancel out the m. So the answer is 0.48. Example 3. Circular motion level curve. The formula is V equals to Z mu Rg. Centripetal force is equal to frictional force. From this free body diagram, N points opposite with mg, while centripetal force always point to center of the curve. Question for level curve. Given the velocity of the car is in km per hour, so we need to change it into meter per second. So we get 8.33 meter per second. Then we just substitute the value into the equation. Solve for mu s, and the answer is 0.71.
Okay, so this is the diagram for the forces acting on an object when placed on a bank curve. So for example, we have this question here. A driver of a car in a figure above wants to negotiate a curve with a radius of 70 meter and bank through an angle 30 degrees. If the coefficient of friction between tires and road is 0.5, what is the possible maximum safe speed? So we use the formula V equals to the square root of Rg multiplied by the total of sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Then we substitute all the value to get the final answer of the maximum velocity, which the example of friction is for shoes. Friction is the force that contracts a shoe and surface sliding past each other, caused by the surfaces rubbing against each other. The sole of the shoe grips the ground, preventing the wearer from slipping while walking. biking. Different types of shoes have different patterns of grip based on the surfaces.
Okay, let me continue. There is 3 types of soles. There is sport shoes, spike shoes and rubber boot. For example 5, bicycle brake. The friction force resists motion and in turn generates heat, eventually bringing the velocity of the bicycle to 0. Okay, then we proceed for example 6, there is writing. It is the friction which enables us to write. The frictional force is created when the tip of a pen or a pencil is brought in contact with the surface of the paper. Then, for example 7, rubbing of hands for warm. When two hands come in contact and are rubbed against each other, there is some amount of resistance which comes into play. Then, for example 8, railing a nail.